Good afternoon, and thank you all for joining us for our webinar today as we take a look at remote 3D printing for distance learning. Before I hand things over to Sarah to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the GoToWebinar panel as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow. So if any questions do arise afterwards, you can feel free to respond to that email and we'll be in touch shortly. All right, without further ado, I will pass things over to Sarah to get us started.
Awesome, thanks Madeleine. And thank you to everyone who joined us today. So today's presentation will focus, like Madeleine said, on remote 3D printing for distance learning. I wanted to start us off by introducing our team and sharing a little bit about CAD Micro. So to start off, I'd like to introduce our team. So today on the call, we have Ryan Lang, he's our account manager for education, Morgan Morash, he's our technical support manager, and myself, Sarah Mannon, I'm the marketing manager here at CAD Micro. To start with a little bit about CAD Micro, we are proudly 100% Canadian owned and operated. We serve our customers from coast to coast. We have 5 offices across Canada. We have 4,000 plus customers, and we've been in business for over 37 years. Here at CAD Micro, we like to focus on enabling innovation. So our mission is to empower clients with advanced technologies. So we do that in 5 different oceans, as we like to call them. So those are design software, advanced manufacturing, advanced simulations, 3D scanning and metrology, as well as AR and VR. So that's a little bit about CAD Micro, but I wanted to dive right into the meat of the presentation and pass things over to Ryan to walk us through why 3D printing in education.
Thanks, Sarah. Yeah, absolutely. Reason we're here, why 3D printing in education. There's been an explosion in adoption of additive manufacturing within the education sector in the last 10 years, and this has much to do with the evolution of additive manufacturing with the arrival of desktop printers, 3D printers like Ultimakers. With the offerings of a range of materials, increased access, and lower costs, this allows more educators, departments, and institutions to add this technology to their classroom and campuses. With 3D printing in its first 2 decades largely focused on the role of rapid prototyping for parts that would be later manufactured using other materials and processes, the role of 3D printing of today can extend to truly functional mechanical prototypes and final products. Part of this expansion of scope is due to the larger range of materials that can now be used on the platform, from engineering grade reinforced composite to property specific materials. Part of this is possible because of operation costs, material costs, and greater all-around access to the technology. While 3D printers capabilities increase, so do the number of departments and classes that currently use this technology. And more than anything, 3D printing is an opportunity for educators to help students develop 21st century skills that will make a difference in future careers, whether they pursue STEM, STEAM, or follow other routes. In recent years, curriculum integrators, along with instructors in history, social studies, art, languages, and other cultural areas have discovered excellent ways to use 3D printing technology to help students engage. At the grade school level, we're finding 3D printers tend to emerge in homeroom classrooms or libraries, which allows exposure to students to design and or engage them more deeply in other subjects such as math, sciences, and other cross-curricular classes. Going from grade school and elementary school, high school, in the early days of 3D printing within universities, operating the equipment was often considered an advanced skill requiring training. A service within the university managed industrial 3D printers. These labs have now evolved with the arrival of larger range of affordable printers and materials. In some cases, students train in these facilities to operate equipment and master the range of materials for leveraging professional desktop 3D printers like the Ultimaker printers. These students can demonstrate to future employers that they have advanced additive tech training and skills in their respective disciplines.
Thanks, Ryan. I think it's great to see what can be done at each education level with 3D printing. But as we all know, education has been transformed by COVID-19. So as you can see, one key question we should ask ourselves is, how can you teach hands-on when students cannot have access to the equipment and printed parts?
Absolutely. So that's why we're here talking about 3D printing in education, but also remotely. So with the arrival of the COVID-19 pandemic, schools were forced to immediately switch on to online instruction. This was a challenge for serving hands-on experience typically offered by 3D printing. Over the course of that first spring semester and semesters afterwards, educators explored a wide variety of approaches to lesson design in order to complete courses that typically involve 3D printers. Some examples are like the story of how 3D printing labs helped with PPE production. To start off, inspired many educators with real world case studies to highlight in classes and for students. Other things like project-based design competitions for 3D printing objects to help avoid the spread of COVID began to occur. And I know we had an example of door handle openers for when the first wave of the pandemic happened. Many other educators focused on 3D art, design software, and how technology like 3D printing fits with other digital design and fabrication technologies. And so now, now that we've chatted about the different applications for 3D printers in education, we want to dive into what to look for when choosing a reliable 3D printer for educators. Two things that are important and not limited to, but are hardware, but just as important, the software. With the hardware, though, you can ask yourself many questions, and typically these are great indicators of what you should be looking for. Is the build volume, the build volume affects how big your part can be. How small can your small features be at the same time? Is the printer enclosed, which is very important in the educational setting, an air manager that Ultimaker offers? And if so, what's the maximum temperature of the bed and the print head you're using? With the remote printing, can you print continuously? If you run out of material in the middle of a night of an overnight job, will the machine automatically switch materials? Or do you have to wait until you come in the next day inside the classroom or your setting? To that point, is there a camera to monitor the print remotely? And then another thing that I get asked all the time is, how complex is the setup? Can you unbox and start running your machine in 20 minutes, or are you going to need a technician from the manufacturer and special site setup? We at CAD Micro offer both options. A lot of times the ease and ability of setting up an Ultimaker is there, but we're always available for an onboarding session just to make sure you get your printer up and running properly. Dual nozzle printing, which is available on the S5, allows for you to print with two different materials. These can be two model materials or a model material and a support. So printing in two different colors is not an issue. When we find this is an important question. So just as important as the hardware, software has multiple components. The first is the slicer itself. Does it give you enough options to customize settings? This is important in research labs and even down to high school settings. Are there preset profiles to run any material you want successfully? Are there profiles for different objectives like strength and dimensional accuracy? On the software side, sending the print job from the slicer to the printer can be done with a USB, but now we find it's easier for the end user. It can be done via LAN connection or via the cloud, especially in this virtual world of education we're living in. Does the software have the ability to manage multiple printers and print jobs from a central location, which will allow you to monitor, pause, resume, alter the queue, reprint, firm updates, track maintenance, and it may be important in a fab lab or not only in a lab or in a department inside the school, but maybe across the entire school board within the high school setting.
That's great, Ryan. I think the software and the hardware are two big considerations, but there's also materials. So what are your key considerations for materials?
Absolutely, Sarah. Hardware and software are just as important, but materials is a third important, and it's an important segment and probably what separates a lot of 3D printing companies. Many 3D companies have a closed system and their machines only run on their materials. As you explore potential applications, look into open material platforms as well. The more materials you have access to, like the Ultimaker marketplace, the more designs and applications you'll have for 3D printing across the board. Mentioning this Ultimaker marketplace and essentials, this brings me to Morgan, who will dive deeper in the capabilities of the Ultimaker lineup and Ultimaker essentials.
Great, thanks, Ryan. So on this slide, we've just got an overview of the Ultimaker ecosystem to try and bring together everything that Ryan and Sarah had mentioned previously. We've got the hardware, materials, and then on the right-hand side, we've got Ultimaker essentials bundled all together. So I will do a quick demo and show you some of the capabilities of the Cura software and what you have access to in the digital factory as well. Okay, so this is what Cura looks like. It's a very clean UI. It's very easy to use. File open, grab my handy dandy part that I've been using. To get this set up, first of all, you just need to select the part, and I'm going to orient it based on a flat face. Zoom in, grab my face, and then I'll go with the base settings here and slice that. Slicing just prepares it so that the printer can read the part data. Once it's sliced, we'll be able to see a preview here. No layers to show because it hasn't been processed. And then we've also got a tab to monitor the printer that we have selected over here in the Prepare tab. I can pick any of my connected printers. So we have printers across the country that are set up with our account. And I can go in here and I can manage the printer. So I can get a view of the webcam to see what it's printing, who's printing it, how long has it been printing for. So I'll dive back into some other features here. So the Ultimaker marketplace, this is really important and a powerful tool because it will allow you to grab plugins that will quickly and easily apply different settings changes or allow you to modify your part files directly within Cura. You can also use third-party filaments, and all of these material profiles are going to be vetted by the Ultimaker team, so there's no guesswork. And there's a range of filament providers as well as just different filament types. So you can go from your very basic just PLA all the way up to more high-end fiber-filled materials. And then finally, we have a view of what profiles I actually have with my instance of Cura. Now we'll just jump into the web version of Marketplace. And again, we see a similar view here. Can look at some digital factory integrations. And then the material selector is a pretty powerful tool. You can filter it based on your printer type, what kind of print core you have, if it's certified fully by Ultimaker, and if it's compatible with any of their accessories. You can also pick based on material characteristic that you're looking to achieve in your parts, or you can filter it by a specific brand. Now, in order to send this print to a printer, you can do a couple of things. You can send it directly over the cloud from Cura. You can save it to a digital factory library, or you can save it locally, and then you can put that on a thumb drive and print directly from the printer's USB port. Now that functionality can be disabled so that you have better control over your fleet, and that is one of the features of Digital Factory. So for now, I will just save this to my library, save it to my March folder, and I'll give it a second name. Okay, and now we will use our Manage Printer link to jump into the Digital Factory. And from here, we'll get a look at what's going on with this particular printer. It's currently printing. Let's see what it's doing. We've got, now we can't see much because it's a long print and we are just near the start, so the build plate hasn't been able to drop very far. We can take a peek back to see what's been printed, how long it took, and the general settings of that job and who is printing it. Now from the main page, we can see our whole fleet here. We can see what each printer is up to, and then we will take a look at print jobs. We've got these two printers are currently printing, and now we'll take a look at the queue. So I have this one queued up, and now we'll take a peek at the print history. And it just shows you a history of all of your jobs. And now, as Ryan was mentioning earlier, there is an area to monitor the maintenance on your equipment. So you click the three dots, go to maintenance, and it has recommended intervals for when you should be doing these basic maintenance procedures. And so up here you have what you need to do right now, what's scheduled, and who did what and when they did it. So now we'll take a look at this library feature. I created this folder for the demo purpose of this webinar, and you can see kind of the history of jobs that I've been saving here. I have this one that I was working on today, and that is with Blue PETG, and I had done this one previously with Tough PLA. From here, you can send it to a printer. If I want to send it to Montreal to print, we can do that. You can also download it if you see something that you like, or if you see somebody has processed it in PETG, you want to download it and print in AVS, you can do that. Or you can remove it if it's something that you no longer need. So we will go back into the printers and then check it out here. I have it queued up. If for whatever reason I want to then try to print that on a different machine because I need it tomorrow and there's a day left on this print, I can send it to my other S5. And again, I can delete the job from the queue or reprint. So I'll just quickly hop back over here to Cura and just show you how you can access files directly from your Ultimaker Digital Factory library. File open, you can open a local file or from the Digital Factory. And I will get the one that I did with the white material that we saw a moment ago. Ask me if I want to bring in just the model or the project, so that's all of the settings. And we'll bring that in. And you can see here that it's brought in the material that I was using, as well as the print core, and the settings have changed a little bit. So now if I wanted to make any modifications, I can, and then I just need to hit slice, and then we can send it to the printer, send it to Digital Factory, or save it locally and then proceed however we would like. So I think that that is pretty much what I would like to have demonstrated for today, and then we can hop back into the presentation.
Awesome. Thanks, Morgan. That was awesome. So we're going to just walk through one customer case study that we wanted to highlight here before we pass it over to questions. So one of our customers was the University of Victoria, specifically a research project called the Victoria Hand Project. So they were using 3D printing to provide low-cost prosthetic care in developing countries. So they first started trials in Guatemala in early 2015, and they had participants in the trial keep the prosthetics hands since they did not have a prosthetic device of their own. So then this spurred their idea for a nonprofit organization focused on providing low-cost prosthetic care in developing countries using 3D printing. So they expanded their fleet of printers, and now they have at least one of 26 Ultimaker 2 Plus printers in 9 different countries running at one time. And one thing they did highlight to us was that the printers and the materials function very well in all the different climates. As you can see, they've been in 9 different countries, so it's 9 different climates that they have to kind of get accustomed to. And they found that, you know, they never have major issues with differences in climate, which is fantastic to see. So the Victoria Hand Project does the prototyping at the lab at the University of Victoria, and then they send the design files out to the partners around the world. So similar to kind of the process that you saw Morgan walk through. And when they are prototyping a new design, such as the release of their new hand, the V300, they have their printers running almost 24/7. So they've been able to see tons of use from the printers that they have, and it's been super successful for them. And they have continued to grow and help more and more people. So it's been a fantastic kind of story to be a part of, and it's exciting to share. So awesome. So now we'd like to pass it over to questions. So if you have any questions for us, please type them in the chat now. We'd love to answer any questions about the software, hardware, anything from Ultimaker Essentials. And I'll pass it over to you, Madeline, to get us started with those questions.
Yeah, thank you, Sarah. So we do have a couple that are in the queue already. So we'll go ahead and get started on those. I have a question here for you, Ryan, and it is, what are the benefits that come with Ultimaker Essentials?
Yeah, so absolutely. Like as we just went over with Essentials, I think the importance isn't on just the remote learning, but also the collaborative learning between different departments, different users, or as I mentioned before, different schools. If you have different Ultimakers spread out across an entire school board, school A can collaborate with a school across town without ever meeting and sharing files like that. So with Essentials, I do think the collaboration, the remote learning, and then as Morgan touched on earlier, the wide range of materials. You're not just pigeonholed with Ultimaker materials. You can branch out to many other offers that are different options. So.
Awesome, thanks, Ryan. I have a question here for you, Morgan, and it is cloud-based 3D printing secure?
Right. Yeah. So Ultimaker wouldn't have brought this one to the market if they hadn't had security in mind. Anything that is going from your system, your digital factory account and organization back to Ultimaker is 100% encrypted, and only authorized people at Ultimaker can see it. So not everybody in the organization can just hop in and see what you're printing. And it's not even sharing exact part data. It's kind of telemetry data, some ones and zeros about how your fans are revving and what heat your print cores are at. The and they follow ISO security standards, and it is assessed by a third party to make sure that everything's up to snuff.
Great, thank you. And Ryan, I have another one here for you, and it is, what makes Ultimaker stand out from other 3D printing solutions?
Great question. I guess what stands out about Ultimaker, again, what we've hit on, but also first and foremost, the safety, the reliability of Ultimaker, but also the safety that they have with their HEPA filters, which is again very important inside the school setting with their air managers. You can build out your printer, but the air manager is always accessible to each printer. Other things that just Morgan mentioned, I think it's really important just to key on that. You have control of the printer. If you have a teacher, he can control and see everything that gets printed before it even gets printed. So another key aspect, I think, with Ultimaker and their software is you can see the cost of what each print comes before you print it. I think that's really important in a school setting with budgets and things like that. You don't want to be surprised ever, especially what kids want to print. So just I guess to sum it up, the reliability of the Ultimaker printers and all these features that come with it for educators to be in control of what's going on inside the classroom.
Awesome, thanks, Ryan. And we have time for one last question. So I'm going to direct this to you, Morgan, but Ryan, feel free to chime in. It is, what are the best sources for training for hardware and software?
So the best sources for training, with the Digital Factory, you're going to have access to the Ultimaker Academy, and there's lots of resources there that will show you some tips and tricks for Cura, as well as general hardware maintenance. And then if you're looking for resources from us, we offer support for your printer setup, maintenance, as well as with Cura. And we have different levels of courses that we would offer, along with install or on demand based on your needs.
Awesome, thank you. So that is all that we have time for today. If any questions do arise after we have finished here, please do not hesitate to reach out to your account manager or reply to the webinar email and we'll be in touch. Once again, thank you guys so much for a great presentation, and thank you all for joining us here this afternoon. We hope to see you again soon. Thank you.